Okay, this is the third video in my series of how to balance chemical equations, uh, doing it in terms of solving a system of linear equations. Because we know how to solve a system of linear equations using matrix methods if by no other means. And it turns out we can use these same matrix methods to balance a chemical equation because for myself, historically, when I was given a chemical equation to solve, the only way I knew how to do it as a student was to basically guess and try. And but the problem can be set in a way that requires no guess and try, but you can actually solve it down and get the solution in a straight analytical method. Okay, so this is the third, as I said, the third video in my series. So I'm going to uh, assume that you understand some things that I have done so far, and let's work through this and see how efficiently we can go through it and have you still understand it. Okay, here I'm taking this chemical equation right here, where I have KMnO4 plus HCl on the left side of the equation, KCl plus MnCl2 plus H2O plus Cl2 on the right side of the equation. And if you remember, what I do is I set up a matrix where the columns of the matrix go with each compound, and the rows on the matrix go with each element that appears. So I start with K, that's the K row is the first row, the Mn row is the second row, the O row is the third row, the H row is the fourth row, and the Cl row is the last row, the fifth row. And then what I do is I go down the column, and I put in as an element in the matrix, I count how many atoms there are in that element. So there's one K, there's one Mn, and there are 4 oxygen here, 4. Go over to HCl, there's no K, so I put a 0 here, and no Mn, I can put a 0 there. There's one H and one Cl. Now, if you remember, for all the elements that appear on the right side of the equation to be balanced, what I do is I put in negative numbers for all those, for the numbers in the matrix, okay? So there's 1K, there's a negative 1, 1Cl, there's a negative 1. I could have put zeros here and here. There's no K, there's 1 Mn, so I put a negative 1. There's 2 Cls, so I put a negative 2 here. Okay, there's no K, no Mn. There's one oxygen. This is the oxygen row. I put a negative 1 there, 2 hydrogen, a negative 2. And over here, there are 2 chlorines. So all these would be 0. I put a negative 2 down there. So that's the matrix that I'm working with to balance this chemical equation. Okay, so, and what I need to do is, you can think of this as this row times this column is equal to 0. So 1 times A minus 1 times C is equal to 0. Over here you have 1 times A minus 1 times D is equal to 0. Here's 4 times A minus 1 times E is equal to 0. You get the idea there. Okay, now let's go back and look at this matrix here that I have written. And what I want to do is I want to take this matrix and I want to put it in an upper triangular form. So I want to perform elementary row operations on the rows to get some of these rows that have all 0 elements below the main diagonal here. So I'll go through those series of steps. I have the rows numbered, row 1, row 2, row 3, row 4, row 5. Okay, so immediately I can see that, for example, I can take row 3 has 4 O's in it, right? 4 oxygens. So I can take 4 times row 1 and subtract it from row 3. And I'm going to put that answer into row 3. So that's the first thing I do right here. Take 4 times row 1, subtract it from row 3, and put it in row 3. Then I also just simply subtract row 1 from row 2 and put that in row 2. So I subtract row 1, this row, from row 2, this row, and replace it back into row 1. So for example, the 1 minus 1 gives me a 0. I'm sorry, I put it in row 2. 1 minus 1 gives me 0. I put that in row 2. When I subtract this, I get a plus 1 here. And I'm subtracting 0 from negative 1, so that stays negative 1. So I do those two operations, okay, and I end up with this now as my new matrix, okay, 1, 0, negative 1, 0, 0, 0. I put zeros now in all those empty places, okay, and this is after I've performed those row operations on row 2 and row 3, so I have this, okay, so now I can take, for example, take row 5, and I'm going to subtract row 4 from it. So 0 minus 0 is 0. 1 subtracted from 1 gives me 0. 0 from a negative 1 leaves me still with the negative 1. 0 from negative 2 is negative 2. When I subtract a negative 2 from 0, it becomes a plus 2 here, and 0 from negative 2 is negative 2. Then I take I add to that, and I add row 2 to that. So after I do that subtraction that I just talked about, I add row 2, and then I take that whole thing and I put it in row 5. So let's see, you can work through those steps, and this is what I get right here. Okay, so I have row 5 now, looks like 0, 0, 0, negative 3, 2, 2. Okay. And and the green, notice that the green represent most of the numbers that have been changed are now represented in green. So I still have this 1 here, okay, that doesn't seem to be going anywhere. Now I could just swap row 4 and row 2 to bring that up and put it up there. What I'm going to do, I'm looking at row 3 here, and I'm going to try to get rid of this row 3. And what I'm going to do is subtract from it 4 times row 2. So here's row 2. I take 4 times row 2, subtract it from row 3, and I put that back into row 3. Now 4 times 1 is 4. 4 subtracted from 4 is 0. 4 times negative 1 is negative 4. Subtract a negative 4 from 0, and I get a plus 0. So you get the idea what's going on there. So I do that. Now this is what I get right here. Okay, I have this, I have this, I have this, and I have this right here. Okay. Now let me see what I can do about the 3 here. I can do, if I want to get rid of this negative 3, I do 3 times row 3. That would give me a 12 here. Then I do 4 times row 5. That would give me a negative 12 there. And if I add 4 times this row, or I'm sorry, 3 times this row to 4 times this row, this thing disappears right in here. Okay, 3 times this row is negative 3 over this number here. 4 times this is 8, and if I add those, that gives me a 5. Okay, so this is how I get rid of that negative 3 down there, by performing this operation on the rows. And this gives me this right here. Okay, now I almost have all zeros down there. What I'm going to do now is I'm going to reorder the rows. One thing to do is just take this row and bring it up here. That gets rid of that. 1 brings the 1 back up here right on the diagonal. And so let me reorder the rows a bit. When I do that, I have this expression right here. Okay, again, I've got, after I do that reordering, here's my diagonal, and they're all non-zero terms on the diagonal. They're all zeros below that diagonal, so this is exactly the form that I want. Now, I have, how I interpret this matrix is I have 1 times A is A, minus 1 times C, And if you remember, although I didn't write it down in the beginning, this is all equal to 0. 0, the column vector, which is 0, 0, 0. So I have A minus C is equal to 0. I look down here, this is B minus 2E is equal to 0. Okay, this is C minus D equal to 0. This is 4D minus E equal to 0. And this is 5E minus 8F is equal to 0. So I look at this matrix, and I can now interpret that matrix as these 5 linear equations for the unknowns A, B, C, D, E, and F. And that's what I want to find the values for A, B, C, D, E, and F. So remember the little method I used to do that. I look at the first equation, and I look at the coefficients of the multiplying A and C. Actually, I look at the absolute value of the coefficient for A and E. The absolute value of that is 1. This is a negative 1 here. The absolute value of that is 1. So I look for the least common multiple of 1 and 1. And the least common multiple of 1 and 1 is 1. Here I have 1 and 2. Again, recall I'm looking at the absolute values of these numbers. So the least common multiple of 1 and 2 is 2. I look at the least common multiple here, it's 1 and 1. The least common multiple of that is 1. And the least common multiple of 4 and 1 is 4. And down here I have 5 and 8. The least common multiple of 5 and 8 is 40. So that's what I have here. So I have 1, 2, 1, 4, and 40. Now, how do I find the values of A, B, C, D, and E, and F? Well, I go to the equation that has the largest least common multiple. That's this one. And what I do is I'll take 40, divide by 5, and that gives me the value V. So 40 divided by 5 is equal to 8. That's the value V right here. Then I take 40 divided by 8, and that gives me the value of F. So I have 40 divided by 8 is equal to 5, and that's the value of F. So that's how I find the value for E and F. And once I find E and F, I can use these other equations to help me solve for the other values. So for instance, if I have E is equal to 8, so E is equal to 8 right here. If E is equal to 8, that's telling me that B, what must B equal if E is equal to 8? B must equal 16. If I have E is equal to 8 here, okay, then D must equal 2. So you see how I'm doing this? If this is equal to 8, in order for this whole thing to be 0, D must equal 2. If E is equal to 8 here, in order for this whole thing to be equal to 0, B must equal 16. Okay, and C is equal to D. I just said D was equal to 2, so C must equal 2. And if C is equal to 2, then A is equal to 2. So here's then the solution. I have E is equal to 8, F is equal to 5, D is equal to 2, C is equal to 2, A is equal to 2, and B is equal to 16. So I can now put those numbers in, and I say the solution to my equation is A times this compound, A is 2, plus B times this compound, B is 16, is equal to C times this compound plus D times this compound plus E times this compound plus F times that compound. So this is the solution to that balancing this chemical equation. This is the solution. Now, hopefully at this time, you're beginning to catch on a little bit as to what the pattern and the solution happens to be. So that is, that's how I solve that problem. Now I can do one more here. Let me do one more here. Okay, here's my chemical equation right here. Okay, AlOH 3 plus H2SO4 plus Al2, and then I have SO4 3 times plus H2O. So these are the compounds that define my columns. I write down the elements on the rows. I have aluminum here. There's Al. I have O. I have H. And I have S. So relatively compact array. I have one aluminum, 3 oxygen there. 3 times OH. 3 H. Okay, and there's no sulfur in here, no S. Over here I have no Al. I have 4 O. I have 2 H. And I have 1 S. And then I do the same thing on these columns. Now remember I said the right-hand side of the reactive equation, of the equation to be balanced, I write in my numbers, but I give all my numbers negative signs. Now I take that, and now I just write this in its matrix form. And here's the way it is right here. Here's the matrix for that. And I want to take this matrix and I want to put it in upper diagonal form. Okay, so, and that's relatively simple for this problem here. For instance, I could take this row, multiply it by 3, and I subtract that from the second row, and I take those answers and put them in the second row. Okay, I can do that. I can take this row, and I do something similar to get rid of the first terms in the third row. So I do some elementary row operations to go from here to here. And I'll let you figure out exactly what all those row operations are. Okay, it's not too terribly complicated. Okay, then I do a few more operations to go from here to here. Now notice one of the things I've done is I've rearranged the order of 2 rows going to here. So, but this is my matrix. This is the upper triangular form where everything below the diagonal is 0. And you say, wait a minute, here's the diagonal, and I have a 1 below it. That's right. But if I just swap the order of this row with this row, then I clearly am in upper diagonal form. So I'm not even going to bother to do that because it doesn't change the result from this point on. So I look at my first equation. It's A minus 2C equals 0. I have 6C minus D equals 0. And I have B minus 3C equals 0. Okay, so I do, again, as I look for the least common multiples of the coefficients. My coefficients are 1 and 2. Least common multiple of 1 and 2 is 2. Coefficients are 6 and 1. Least common multiple of 6 and 1 is 6. Coefficients are 1 and 3. Least common multiple of 1 and 3 is 3. So here's the equation with the largest least common multiple. So what do? I take the least common multiple and divide by 6, and that gives me the value of C. Okay, so that's 6 divided by 6 equals 1. That's the value of C. I take the least common multiple 6 and then divide by D, or divide by 1. That gives me the value of D. 6 divided by 1, this should be, I don't know why that says B, whatever, right there. It should be 6 divided by, wow. 6 divided by 1 is 6, and that's the value of D. Okay, so that's what I have there. And now I can go back and look and use the other 2 equations, and I can solve here. You know, for instance, if I have I have C is equal to 1. If C is equal to 1, then B is equal to 3. So that gives me B equal 3. If C is equal to 1, for this equation to be true, then A has to equal 2. So the answer to my problem here is A is equal to 2, B is equal to 3, C is equal to 1, and D is equal to 6. And here's my balanced chemical equation right here, shown right here. A is equal to 2, B is equal to 3, C is equal to 1, and D is equal to 6. Okay, so I hope, having gone through these several examples, you are catching up on the solution, on the technique for solution that I use. You may not fully understand all of the mathematical details just because you haven't gotten to study the relevant mathematical theory yet in your algebra courses. But nevertheless, this really works pretty well on finding the solution to balancing chemical equations. Okay, until next time.